everyone, in this unit we're going to talk about naming ionic compounds. Now naming ionic compounds is a little bit challenging, but I'm sure you can conquer it very easily. I'm going to guide you through the process. We're going to do some together and then we're going to do some on our own. While we're naming ionic compounds, it is important to remember where the metals and nonmetals are found on the periodic table. So you're definitely going to need your periodic table out during this. So you're going to want to go ahead and take that out, okay? Find a good periodic table if you're Googling one online, or pull your paper one out, and we're going to go ahead and get started. All right, so naming ionic compounds. So the first thing we need to refresh our memory on are where the metals and nonmetals are found. If you recall from the last unit, where are your metals found? Metals are found on the left side of the stairs. Nonmetals are found on the right-hand side of the stairs. The only exception to this rule is hydrogen. Even though hydrogen is found on the left-hand side, it is still a nonmetal, okay? So metals and nonmetals, they make up three different types of bonds. Now in this unit, we're just going to do a brief overview of what makes up each type of bond. In another unit, we'll talk about more specifics, more characteristics of each type of bond. But for now, we just want to know what makes them up. So an ionic bond, it is made up of a metal and a nonmetal. So that's one element from the left side of the stairs and one element from the right side of the stairs, with the exception of hydrogen. Don't forget, that's your exception. Covalent is two or more nonmetals. So that's two or more elements from the right-hand side of the periodic table plus hydrogen. And then the last type of bond is a metallic bond, which is two or more metals. Now for this unit, we're going to focus mainly on ionic, so metals and nonmetals, but I want you to be aware of what makes up a covalent bond too. So we're going to practice identifying ionic and covalent bonds, and then we're going to practice just naming ionic bonds in this unit. So it's important to remember that ionic is a metal and a nonmetal, and covalent is two or more nonmetals. So let's practice. Can you identify if a compound is ionic or covalent? So the first one is N2O3. Take a minute, find nitrogen and oxygen on the periodic table. They are both on the right-hand side of the stairs. Since they are both on the right-hand side of the stairs, it is a covalent compound. All right, let's do the next one. P and O. Take a minute, find P and O on the periodic table. They are both on the right-hand side of the stairs, so it is covalent. All right, number 3, FeCl3. Take a minute to find Fe and Cl. Now, Fe is on the left of the stairs, Cl is on the right, so it is going to be ionic. The next one is AlPO4. So this has 3 elements in it. Al is on the left of the stairs, so as soon as you see one metal that is to the left of the stairs, you know that it has to be ionic. And the metal will always be listed first, okay? Next one, NO2. N and O are both on the right-hand side of the stairs, so it has to be covalent. All right, LiBr. Li is on the left side of the stairs, so it has to be ionic. SO3 are both on the right-hand side of the stairs, so it must be covalent. CH4. Take a minute and find carbon, find hydrogen. Both carbon and hydrogen are considered non-metals, or on the right-hand side of the stairs. Remember, hydrogen is that exception. The next one is Na2CO3. Take a minute and find them. Na is on the left side of the stairs, and as long as there is one metal, it is called ionic. And then the last one is NaF. Once again, we know that sodium is a metal, so as soon as you have one metal, it must be ionic. Perfect. Now on the next screen, I want you to pause the video and try these on your own to practice identifying ionic or covalent. So make sure you pause my video and practice those on your own. All right, hopefully now you paused the video, you tried these to identifying ionic or covalent, so let's go through the answers. NaOH is ionic. Na is your metal, so as soon as you have a metal, it's ionic. What about K2O is ionic? Potassium is a metal. Ka Ki, it is ionic. Potassium is a metal. BaSO4, it is ionic. Barium is a metal. HCl is covalent. Hydrogen and chlorine are both nonmetals. Remember, hydrogen is the exception to the rule. H2O, oh, we all drink that. It is a covalent compound. NH4Cl, now there's 3 elements here, but none of them are metal, so it has to be covalent. CO2 is covalent. MgO, Mg is ionic, MgO is ionic, Mg is your metal, oxygen is your nonmetal, and CaCl2. Calcium is our metal, so as soon as you see a metal, it is ionic. Perfect. Hopefully now you can identify the difference between an ionic compound and a covalent compound. That is extremely important. In this unit, we're going to focus just on naming ionic compounds. So instead of saying K2O, we're actually going to name it and call it potassium oxide. So there are a few steps you need to follow when naming ionic compounds. First thing you always want to do is ask yourself, is it ionic or covalent? Now, I've already said that in this unit, we're going to just focus on ionic. However, when we add covalent in, it's very important that you ask yourself which it is. Ionic and covalent both have 2 different processes for naming, okay? The second question you want to ask yourself, is the metal a transition metal? So let me jump to a periodic table really quick. Remember, our transition metals are all in groups 3 through 12. So that's this middle section right here. If it's a transition metal, that means it's special and you have to do something specific when you're naming it. There are a few other additions to transition metals. The other transition metal exceptions are tin and lead. So transition metals are groups 3 through 12 plus tin and lead. Now, a transition metal is important because transition metals can have more than one type of charge. Typically, metals only have one type of charge, but though transition metals can have a +1, a +2, or a +3, depending on what they are bonded with, okay? So, transition metals, ask yourself that. All right, if there is no transition metal, you're going to write the metal as is, and then if it ends with a non-metal, you're going to change the ending to IDE. And if it's a polyatomic ion, you're going to write it as is. You're like, whoa, what is this? I just said a ton of information. I'm going to go over it again. So the metal is always listed first, and that never changes. You're always going to write lithium as lithium, sodium as sodium, calcium as calcium. So that's always as is. Now the non-metal, we're going to change the ending if it ends in a non-metal. So if it ends with chlorine, it's going to become chloride. If it ends in oxygen, it's going to become oxide. Nitrogen becomes nitride. Hydrogen becomes hydride. Fluorine becomes fluoride. Sulfur becomes sulfide. Bromine becomes bromide. Okay, so those are the most common ones. Now, I didn't go over all the nonmetals. However, you get the gist of it. I'm not going to take off for spelling. If it's close, I would accept it. Okay, so that's important to keep in mind. Now, a polyatomic ion. First, I want to reiterate that I'm not going to make you memorize these this year, okay? You do not have to memorize this. This is a chart that you will have access to during your practice, during a test, during a quiz. I'm not making you memorize these. So a polyatomic ion is a charged compound made of 2 or more nonmetals. So these are nonmetals that are combined and often combined together. So they have common names for them. It's things we see all the time. I want to point out a couple things here. I want to point out acetate first. If you notice, there are 2 acetates. However, the first formula is C2H3O2. The second one is CH3COO. It can be written in 2 different ways. There are 2 carbons in each. There are 3 hydrogens in each, and there are 2 oxygens in each. So both of them are acetate. It's just a matter of which way do you write it. Okay. The other thing I want to point out are make sure you look at your subscripts, because here we have no subscript, which is a 1, then we have a 2, a 3, and a 4. Here we have 3 and 4, and those subscripts often determine what the ending is. So here we have a subscript of 3, so it's sulfite. Here we have a subscript of 4, so it's sulfate. So going from 3 to 4 changes our ending from ite to ate. Typically, ite is the lower number and ate is the higher number, okay? So it's just different things to keep in mind. Make sure you're looking at the correct one because that does occur in a few spots. Here we have NO2, nitrite, NO3, nitrate. So those are the things that, we want to keep looking out for. And the charges are there as well. The charges typically do stay the same, so sulfite and sulfate both are going to have the -2 charge, okay? But I'm not making you memorize this, all right? So if there is a transition metal, that's when there are a few extra steps. You're still going to write the name of the metal as is, so the metal never ever changes. And then you have to use a Roman numeral, okay? A Roman numeral will always follow that transition metal, but then the second part stays the same. The nonmetals still get the IDE ending, and the polyatomics are still going to be written as is, okay? So, quick review on Roman numerals. If you don't remember what they are, 1 through 5, take a minute, review it, write it down. These are the most common ones we're going to see. Okay, the other thing that I want to give you, because when we're doing transition metals, you do need the charges for the groups, and this is going to come in handy. So just a reminder, group 1 is going to have a +1 charge, group 2 will have a +2 charge, 13 is going to have a +3, 15 is going to have a -3, 16 will have a -2, and 17 will have a -1. So we're going to talk more about how we got those charges in another unit. However, I want you to be aware of this for now. So I would give you this on a test or quiz for the time being as well. So metals, remember, have a positive charge, and nonmetals are going to have a negative charge. Positive are always losing electrons, they're always willing to give them up, and nonmetals are always greedy and they're taking them. So that's why nonmetals have that negative charge and metals have the positive one. All right, so let's do a quick review before we start trying some practice. I know we went over a lot of information, but the best way to get better at this is to practice, practice, and practice, okay? So what happens to the ending of a nonmetal? The nonmetals always get the IDE ending. What happens to the ending of a polyatomic ion? That one is a trick question. Nothing ever happens to them, okay? When is a Roman numeral used? A Roman numeral is only used when you have a transition metal. Okay, so let's do some practice together. All right, we have NaCl. Okay, I am going to actually flip, and I'm going to write some. I'm going to flip, and I'm going to write some of these on my board so you guys can see it with me. So what you just heard was my board crashing down. Okay, so we're going to do some of these together. Okay, notice I covered up the answers. All right, here we go. So our first one is NaCl. Hopefully you can see that. So Na we know is our metal. Is it a transition metal? Is it in the middle of groups 3 through 12? It is not. So we don't need Roman numerals. So we're just going to do Na. Na is sodium. And then Cl is our non-metal. And since it's a non-metal, remember we said that all the non-metals get the IDE ending, so chlorine becomes chloride. Okay? All right, the next one. The next one is K3PO4. Okay? Is K, or potassium, a transition metal? It is not. Potassium is in group 1, so it's not a transition metal. So we're going to write it as is. So K is potassium. Now, PO4. So PO4, remember, is our polyatomic ion. So we would come over here, look for PO4. We see PO4 is phosphate. So K is potassium. PO4 then is phosphate. Okay? Perfect. The next one is CaI2. Okay. All right, is calcium a transition metal? It is not, so we write calcium as is. And then I is iodine. It is a non-metal, so it becomes iodide. You change the ending to IDE. Okay, so we have metal and non-metal. Metals always stay the same. Non-metals always get the IDE ending. Okay, here we have K3PO4. We had a metal and a polyatomic ion, so metal stayed as is. We had our polyatomic ion. Okay, so those are two different examples. We have metals and nonmetals, metals and polyatomic ions. Okay, now I'm going to erase this, and this is where we're going to start doing transition metals. All right, so our first one is FeNO3. Okay, so our first one is Fe. We know that Fe is iron. Iron, if you look at your periodic table, is in group number 8. So iron is in right here, it's in group number 8, so we know it's a transition metal, okay? So since it's a transition metal, it has to have Roman numerals after it, so those are going to go in parentheses, so I'm going to put those in right away. Now, NO3. NO3 is a polyatomic ion. So since it's NO3, we look here at our chart, we see that NO3 is nitrate, so that stays the same. Okay, now that part is easy. This is where it gets a little bit tricky. I'm going to slide this over here. So now we have to look at the charges. NO3 has a charge, if we look at here, of -1. So I'm going to draw a line separating my metal from the rest of the periodic, from the rest of the side. So draw the line, metals on the left, the polyatomic ions on the right. We said that NO3 had a charge of -1. Now, how many NO3s are there? There are 3 of them. There are 3 NO3s. So -1 times 3 is -3. If the right side is -3, the left side must balance it out and be a +3. The left and the right must equal each other, okay? I know that's a little tricky, so I'll review it one more time. I drew a line after my metal. I found the charge of my polyatomic ion, which on the chart is -1, which is nitrate. There are 3 of them. Because this is the symbol NO3, there are only 3 of them. So -1 times 3 is -3. If the right-hand side is -3, the left-hand side is +3. So 3 divided by 1, remember if there's no number, it's a 1. I want you to get in the habit of dividing by 1. So that way, I know that's a little small, hopefully you can see it now. So that way it becomes a habit because this is not always 1. So 3 divided by 1 is 3. So then in parentheses we have 3. So our answer then will be iron 3 nitrate. Okay? I know that one was a little bit tricky. Transition metals typically are the tougher ones that give people a challenge. Okay? Now let's do another one. This one is very similar. It is still Fe. It is still NO3, but this time it has a subscript of 2. Okay? So we know that iron is a transition metal, so we're going to go ahead and write iron. We know it's a transition metal, so we know it's going to get parentheses. We know that NO3 is nitrate from the polyatomic ion sheet. Okay, now we have to do the charges. So I'm going to draw the line. I know from before that nitrate had a -1 charge. So -1 times 2 is -2 on the right-hand side. If the right-hand side is -2, the left-hand side must be +2. 2 divided by 1 is 2. So then in parentheses, we have a Roman numeral of 2. So iron 2 nitrate. I know there's a wicked glare right there. Okay? So iron 2 nitrate is your final answer there. Okay? I'm going to jump back over here. I'm going to go back to here. So these were your answers. So I understand that the transition metals are the tougher ones, but it's very important to practice those in order to give you guys, in order to get better at it, because that's the best way to do it, unfortunately. Okay? All right, let's go back to this. All right, I want you to take a minute, pause the video, and try these 5 on your own, okay? I'm going to erase my board. I want you to take a minute, try these 5 on your own, and then we'll go over them together. All right, so hopefully you took a couple minutes to practice. The first one is AlCl3. It's a metal and a nonmetal, so the metal stays the same, and chlorine becomes chloride, okay? I'm going to exit my full screen again, and I'm going to do these with you guys because a bunch of these are transition metals, okay? So, hopefully I'm going to slide back over, and you guys can see me. Okay, so the first one is Cu2SO4. All right, so let's look at Cu. We know that Cu is copper. Copper is a transition metal. Copper is a transition metal because it is in groups 3 through 12, so we know it needs Roman numerals. Okay. Since it gets the Roman numerals, it has to have parentheses. Now, SO4 is sulfate, according to your polyatomic ion sheet, so sulfate stays the same. Okay, now we have to draw our line and separate the left side and the right. We look at the charge for sulfate. We know that sulfate has a charge of -2. Now we are not going to multiply this time because there is no parentheses, okay? So when there's no parentheses, we're assuming that there's only one of them. So -2 times 1 is a -2 on the right-hand side. If the right-hand side is -2, the left-hand side must be +2, okay? So 2 divided by 2 is 1, okay? So the answer is copper, 1, sulfate. Now the beauty of this video is you can rewind and rewatch certain parts if you don't understand, and then ask me questions. All right, let's do the next one. HGS. Okay, so Hg, we take a look to find it. We know it here, we see it here, so it is a transition metal. So Hg is mercury. It is a transition metal, so we know it has to have Roman numerals, so it gets parentheses. Okay, so now we just have S. So S is not a polyatomic ion, it is a non-metal. So sulfur becomes sulfide. It gets that I-D-E ending. So sulfur becomes sulfide. Okay, I know there's a wicked glare right there. Okay. Now we have to do the charges. So I'm going to divide the left side and the right side. Now, how do we get the charges? If we take a minute and we look at the periodic table, we can see that sulfur is in group 16. If you go back to your notes, anything in group 16 is going to have a -2 charge. So, since it's in group 16, it has a -2 charge. If the right-hand side is -2 and there's only one, that's -2 on the right and +2 on the left. So it's going to be mercury 2 sulfide. Okay? I'm going to do one more on the board with you. I'm going to erase. And the last one we're going to do on the board together is PbBr4. Okay, so Pb we know is lead. Okay, Pb we know is lead. Lead is in group 14, I'm sorry, but it is a transition metal, is one of those exceptions to the rule. So it is going to get the parentheses for a Roman numeral. Okay, now Br, there's only one of them, so it's not a polyatomic ion, it's a non-metal. Non-metals get the IgE ending, so it's bromide. Bromine becomes bromide, it gets that IgE ending. Okay, now we draw the line. We have the transition metal on the left, the non-metal on the right. So we can go back over here. We see that bromine is in group 17. If I slide back over here to look at the chart, anything in group 17 has a -1 charge. So anything in group 17 has a -1 charge. So -1, there's 4 of them. -1 times 4 is -4 on the right. If the right-hand side is -4, the left-hand side must be +4. 4 divided by 1 is 4, which this is where your Roman numerals come into play. If you don't remember, you can go back and look. 4 is IB. And you would get that on a test or quiz as well. So then your final answer is lead 4 bromide. Okay? All right, there's one more, I believe, to do together. The last one is MgO. Okay, now MgO. Is Mg a transition metal? It is not, it's in group 2, so we know that Mg is magnesium. It is not a transition metal, so no Roman numerals. Okay, and then oxygen is a non-metal. So oxygen simply becomes oxide. Okay, so magnesium oxide. Okay, now I will jump back over here. I'll put this back up. These are the answers if you need to check them. Now, if you were confused, I know we went over a lot. Transition metals are huge, so take some time to review them. Ask me questions. We can set up a meeting if you need to set up a meeting. But do take the time to do the practice. The practice is extremely important this time in order to get better. Please feel free to reach out if you have any questions, and I'll talk to you soon.